This is our video for lesson 6.3. It is filled out already. I'm going to go through this kind of quick, so I expect that you'll probably need to kind of pause and rewatch things a couple times if this is your first time, or maybe even if it's just a refresh. So we're looking at exponential functions, and they are not linear. So what we've looked at in the past have been linear functions, meaning the graph looks like a straight line. These are going to be not linear. So our graph is not going to be a straight line. It's going to be curved in kind of a specific way, and we'll see what that looks like in a little bit. And the equations are going to be of this form, y equals a times b to the x power. So the x variable in this case now is an exponent. There are a few restrictions on a and b that we will get to a little bit later, but you're not going to see any of those in our first few examples. So what this might look like, y equals 2 to the x. This would be the case where a is just a 1. Or y equals 5 times 1/2 to the x. So in this case, a would be 5, b is 1/2, and then we have our variable here. So there's a couple different ways that we can spot this. One would be in a table. And so in our first example, if you remember earlier in the year, we looked at linear equations and we looked at tables just like A here. And what we noticed is that there was this constant difference. So like here, I've got +1, +1, +1. And then there's a constant difference in the y values as well. So we're +2, +2, +2. We could be subtracting in the y values as well. That'd be fine. We can have different numbers here. That would be fine as long as it's just adding or subtracting the same amount. Right? So in linear equations, there's a constant difference in the x and the y. B is an example of exponential. And here, as the x values go up by a constant difference, the y values are going to be multiplied by some constant number. Okay, so notice every time x goes up by 1, y is multiplied by 2. When we get down to example 2, this is evaluating those functions. And this is just basically taking a value of x and plugging it into the equation. So in this first one, our equation is y equals -2 times 5 to the x power. So all I want to look at is when x is -3, what is y? So I would substitute that in just like we did here. And if you punch this into your calculator and you do it properly, you should get -0.016. And why that's the case is if I have this -3rd power, remember, what that does is to make that a positive power that brings it to the bottom of the fraction. So this becomes -2 divided by 5 to the 3rd power. 5 to the 3rd power is 125. -2 divided by 125 is this, -0.016. Not remembering why I had this as an example here. This would actually be a little bit flipped. This would be negative values, so this would end up looking more like this if we were to look at the graph of this. But these are the general shapes of exponential equations. So they're going to kind of run along this axis and then go up quickly, or come down quickly and then run across the axis like in the next example. So here again, we're doing the same thing in part B. Is I'm just taking my equation and I'm plugging in for x. Again, this is a negative exponent. So x could be any number here. If we were trying to look at the graph of this, which we'll do in the next examples. So y equals 3 times 0.5 to the -2. And again, if we just plug this into our calculator, you will get 12. And why that makes sense? So that negative 2 again is going to come to the denominator as a positive 2. And negative 5 squared is 0.25. So 3 divided by 0.25 is 12. And this is like a more accurate sketch of what this graph would look like. A new vocabulary word, that is an asymptote, and that is a line that a graph gets really close to but never touches or crosses. We see that a lot with these functions, these exponential functions, and we'll kind of look at that as we graph these couple down here in example 3. So example 3, part A, here's our equation. F of x is equal to 4 times 2 to the x power. So when you're graphing these, you want to choose some values of x and evaluate. Plot those points, and that will give you the general shape. Once you kind of know the general shape of these, 3 points is probably going to be enough to get you there. It's always good when we're choosing values of x to choose some positive and negative, and it's always good to choose 0, because when x is 0, that's going to give you a point that's on the y-axis, and oftentimes things happen on that axis, and we might see bigger changes somewhere around when x is 0, 1, and negative 1. So just like we did in the previous, I'm taking my equation, I'm just going to plug these values in. So when x is 2, I plug that in and I get y is 1. So negative 2 comma 1, that's this point right up here on the graph. X is negative 1, y is 2. That's this point here. The next one, and then this final one would be off our graph. When x is 2, y is 16. So again, notice that this is growing really quickly. What's happening is we're multiplying by 2 every time x goes up by 1, and it's not a coincidence that this value here is 2, right? That's going to be what we're multiplying by as x goes up by 1. And that's something that we'll look more at in the next chapter as well. So if we're sketching this graph, it's getting big really fast here. What we don't see is as x would continue to get negative, this is just going to get smaller and smaller and smaller and smaller and smaller. It will never reach 0. It will get very, very close to 0, but it will never actually get there. So that's where we would have an asymptote. The x-axis in this case would be an asymptote. And our graph, it can be hard to draw this exactly because you want it to, again, be really close to that axis and show that it's getting closer and closer, but never actually touch. And then we kind of curve up sharply here and add our arrows. We do the same thing for the next one. Honestly, you might want to just try this one on your own if you haven't seen this stuff yet. So our equation, f of x equals negative 1/2 to the x. Make sure you're putting the 1/2 in parentheses. Otherwise, you're going to get incorrect values. I chose the same values of x to plug in. And here's what I got. I plotted those points. And this is where this negative flipped this so that it's down underneath. So again, we would have an asymptote on the x-axis. This is going to come up to that axis really quickly and then level off and get closer and closer to it. So our graph would look something like this. Actually, it would probably be even sharper on this end here. But this is just a sketch, so we're just kind of showing the rough shape of this.